Okay, I will present you for today's webinar. Hello, everyone. Today we have a meetup session with Peter Zaitsev, and he would talk about zero-instrumentation observability based on eBPF. The discussion is going to be 45 minutes, so welcome, Peter, and 15 minutes would be for Q&A session. Thank you.
Okay, thank you. Yes, so let's talk about zero implementation observability. So first, I want to have a little announcement to make. If you are passionate about the observability, especially open source observability, we are putting together a bigger conference, right, Open Source Observability Day, which will take place October 24th. You can attend it live, or you can also look at the talks recording later on. In any case, we would suggest you to go ahead and register to attend. So when I talk about observability, I think some people wonder what the hell is observability? That is complicated word. And those days, if we want to learn something, it's a good idea to ask ChatGPT what observability is, right? And that is what I did, which actually produces this a reasonably coherent mouthful you can read about here. Now, when I think about observability, though, is what comes in my mind is something like their playing instruments. I'm sure many of you, when you travel, picked in a plane cockpit to see how many different instruments we have out there, showing us a whole bunch of stuff, right? And that is their observability. And why I think this example is quite interesting, because there are so many the planes are so complicated, but yet we have so few incidents for those very complicated things, right? And I think significant reason for that is because we also have a fantastic observability, right? The pilots, we really have a very good understanding about how all the plane systems are doing, and if something starts to go wrong, how to fix them. Right. And then, of course, that comes together with some sort of like a checklist, run books, and a lot of training what to do in this case. Right. Now, the other thing to think about is the evolution of the applications, what we have been seeing over the last couple of decades. I am someone who started developing the applications in early 2000s. Even maybe late 90s. And at that time, the world was kind of simple, right? You would have, maybe one or several application nodes which would talk to your database, right? And that was very easy to understand and troubleshoot. In fact, I know many folks involved in operation who just have a shell open to pretty much like all few servers they have, right? And if something goes wrong, you can very quickly log in, check what's going on out there, and fix a problem. Things have changed. Now we have a very complicated and often very large systems. Like if you think about something like Facebook, they are running tens of thousands, or if not hundreds of thousands of servers, right? And huge amount of services, right? Which have a very complicated relationship between them. And that means that approach doesn't really work, right? And that means what the observability has to become very sophisticated those days. So why do we need this observability? Well, it actually helps us with a lot of things, right? Availability of our system, making sure we have acceptable performance for our users, helps us to manage the costs, right? Because we don't want to spend too much money while providing that great performance, as well as security. Now, I'm not really the big security expert, but the first three, availability, performance, and cost, we usually kind of come together and use the same set of tools which allow us to provide all of those free outcomes, free benefits. When you talk about observability, mm, it's often talk about number of pillars of observability. And some people just list 3 pillars, some people list as many as five. I just picked 4 in this regard, right, which I think is a very important one: metrics, logs, tracing, and profiling. Now, what I also did is I had a poll, on my LinkedIn to ask people what is the most important. And of course, it's kind of like a trick question because they are the most powerful if you use them together. But we can see that for majority of the people, metrics are the most important one. And indeed, I think the metrics is the first data point which comes in mind and which you used for troubleshooting, right, for many years. Let's briefly cover those observability pillars and what are they good for. Now, if you think about metrics something which provides us a very good high-level overview, right? You can think, oh, how many requests a second happen, how many errors, right? Is the host up and down, right? That's also all the metrics. And if you look at the modern complicated systems, we often had hundreds of, no, not hundreds, thousands of metrics, which can be collected every second, and that can be displayed on hundreds of graphs, right? And that can be sort of like a, very cool. You have a lot of graphs showing us what exactly is going on in every area of the systems. Now, if you think about the logs, and when you talk about the logs, they're typically not the logs on the picture, but the logs where the application, reported progress, status, errors, and so on and so forth, is something which has structured or unstructured formats, and it can have a detailed information on what is happening. We very often would use metrics and logs together, right? Let's say metrics would tell us, oh, this host is down, or this host is running slow, and then we can perhaps log into that host, or try to log in, right, and check in the logs and see what is going on, right, to figure out the actual problem. Now, if you think about logs at scale, there are a number of difficulties of them. Logs are very expensive to produce and also expensive to store and analyze, right? Especially if you have a detailed logs about what exactly happened with every single, service request which goes in your system. And that means sampling and filtering are often used, right? You may only store like 1% of your logs, or say, hey, you know what? We are only storing the errors or warnings. We're not going to store information about successful requests and so on and so forth. The next thing is distributed system. And it is somewhat related and somewhat similar to logs, but better, right? Because where logs show us the information about what happened with request, right, with application on the given system, distributed tracing helps us to track request as it comes to the front of a system, right, and goes through different services, different layers, right, and then hitting the database and so on and so on, right. And that is very helpful for us to really to understand what's going on with different requests. It's kind of slightly tricky because we need to pass a trace ID between a different services, right? But if you can figure that out, then it's absolutely great for root cause analysis, though it has a similar problems to logs. It's also very expensive to produce and store, and that means it's often becomes sampled. Here is a distributed tracing example, right? We can see, in this case, we can see the different calls. We can see which of requests have been happening in parallel, right? We can see which have been, terminated in error and so on and so forth, right? And that allows very well to understand where performance problems, right, or reliability problems they come from. Now let's talk about the last one. The last one is profiling, and a profiling talks about where the CPU time or wall clock time about when a server request was operating is spent. And it can be focused on a single server, on distributed, right? We kind of, combine the profile from many systems which are running. And the cool thing about the profile, it has the language which is most meaningful for developer, right? The profiler can show you as a developer is, oh, this function is where most of the time works. Figure out how to optimize it. That is also where the comparisons are very helpful, right? If you can compare, the time distribution today versus yesterday, we can say, well, for some reason now this function is running twice as slow. Maybe you did some code changes to that, right? Or maybe there's like some circumstances change. But again, it's very very helpful to focus on what exactly we need to fix. With profiling, it's also very important to provide the specific language support which is needed, right? Because often if you're using, Java or complicated like interpreted programming languages, right? Well, what you care about is the functions in the in the concept of that language and not pieces of generated code which happen to be executed on CPU. Okay, this is a very brief overview of what observability is, which I hope is a helpful primer. Now, the question you may ask is, how do we get all of that observability we want to have in our application, right? And that is where instrumentation comes in. We need to have some sort of instrumentation to get all that data, right? Going back to the plane analogy, for those all the widgets to display us the airspeed, right, and the altitude and so on, there have to be the special, widgets, right, which are operating in a plane to provide that that information. If you think about the systems, there are different types of organizations which exist. One is a static implementation, and that is something where we have certain bits and pieces in the code which produce those numbers, right? Like if you think, for example, plane, it uses static implementation for each and everything, right? It's just instrumentation, which is, constantly sends us data. If you think about Linux, procfs is fantastic example, right? It's always available, and you can always approach it there and say, hey, here's what like how a CPU usage, a load average, right? Or this QDAP looks like. Then there is also dynamic instrumentation. And dynamic instrumentation allows us to basically instrument anything dynamically. You want to know how often is this specific function is called, right? With what parameters, right? You can do it when you need without changing codes. And that is where technologies as dtrace and more recently eBPF has been important. The other angle of approaching instrumentation is about when and where should we instrument, right? Again, our systems, what we work with, they have a large amount of systems pretty often involved, right? Going through different cycles. And what we find is very helpful is one is we have always on instrumentation, right? That is when we always have this data sending us the information, right, which we capture and retain. And the good thing about that is when we can historically analyze that, right? We can sort of look at that and say, oh, well, you know what? I see the website went down, for example. I can look at the data which we captured and see what, 3 hours before something happened, which later converted to a full-blown downtime. The second type is the temporary instrumentation, right? And this goes like this. You can say, well, you know what? I see the system is experiencing difficulties, something is not working right, too slow, right, or whatever, I can go ahead and maybe enable some additional instrumentation, which helps me to debug, to diagnose a problem, right? That's kind of temporary instrumentation often have that like a debugging and things like that. And also, you often see in a large-scale distributed systems where you would have some special nodes, special services designated as the canaries, if you will, which would have a more deep instrumentation, right, and which will help us to validate how we're operating. Sometimes you do it with a new code. Sometimes you just would do that with, let's say just like a very small 1 out of 100 of a services, right, to get some more insights, assuming what, every service has the same load and the same operation, but instrumenting only one of them helps to get much more details. So what is the challenge of that instrumentation? Well, I think it's pretty obvious, right? On one extent, to get a lot of observability, we need to instrument a lot of time, right? And we also need to, instrument a lot of stuff, and we have to also store and process a lot of data, which has a couple of problems, right? The first problem is that instrumentation often comes with code, right? And if that instrumentation comes with a lot of code changes, then it's not getting done, right? I mean, in some cases, because developers don't have that time on their hands, or sometimes you have parts of a system which are just, written by, the third parties where that instrumentation just is not quite possible. And what happens with this is what we get something like as a Swiss cheese of observability, right? Where certain components of your application are instrumented very well, and others not so much. So what goes into making system observability? Well, that means we have to collect a lot of telemetry data, right? When we either instrument it manually, right, or not, when we store that data in some sort of database. And then also the other big challenging part is what we'll need to learn how to troubleshoot your system using all this data. Let's talk about that in a little bit more details. So how can we collect, well, before we talk about how we collect the data, I think it's good to figure out what is actually practically usable, right? What is the most important beyond all those kind of secondary metrics to help us to diagnose their systems. And these are some of the most important data points, right? What we see. I won't go with all of them in details, right? But you can obviously Google to find more information. So if you think about collecting all that data, well, it actually has been achievable without eBPF, right? You can collect all of that stuff, but that often would require either code changes or figuring out configuration where the logs are and so on and so forth, right? But what you can do with eBPF is what you can instrument that in minutes. And that means you can have a view of all your systems and not just focus on the kind of the most critical services and so on and so forth. So let's look into more details. How does that work? So first, what is eBPF? Well, eBPF is a feature which exists in Linux kernel. It is relatively new, but not kind of so bleeding edge, right? So it is stable, and it's most likely is available in a Linux distribution which you're running. It allows you to run a small programs in a kernel space, right? And kind of connect that to any kernel or application function call, which can get that observability you're looking for. It can capture metrics and can emit logs. It can, compute histograms and so on and so on and so forth. Okay, so that is how eBPF works. Now, if you're looking to get more details about eBPF, I would encourage you to check out the eBPF IO website. It's actually very, very cool website, in my opinion, and the team has done a fantastic job in explaining how eBPF works and various use cases and programs and so on and so forth, right? But if you just want a very brief thing, you can see what there is a user space and a kernel space, right? I was saying there is this, small program which runs in kernel, right? And the majority of the data processing happens in the user space, right? So you can really build a very big programs, but they are kind of running asynchronously and cannot slow down or kill the kernel. There is something else which is important in about eBPF, which is managed here. One is eBPF runs in its own kind of JIT code, right, in its own virtual machine, right? So even if there are some bugs in the code, they are not going to crash the kernel, right? In the worst case, we can cause exception of that virtual machine which eBPF is running with, right? So the kernel is safe. The second thing is what eBPF comes with verifier. So those kind of small eBPF programs, they are validated for complexity, right? So they cannot be very slow and long. They, for example, cannot have loops, right? And that provides an additional safety, right? Which is very important because you don't want to, crash your kernel while you are trying to get additional insight. Now, what specifically you can use eBPF with, right, or connect eBPF to? Well, there are a number of different things you can connect to. One is a kprobe, right, which allows you to connect to any kernel function, right? But the kernel functions can be renamed, right? And the arguments can change, right? So it's kind of not very robust, right? Because as developer, you kind of don't even control the kernel, right? Often it's kind of, the change in maybe outside of your control, right? To have things more robust, you are able to connect to a trace point, which are pretty much like defined names in the kernel, right? Which are going to be much more stable, right? And there is agreement what while you refactor the code, you still keep your trace points, right? And they correspond to some specific kernel actions. For example, I'm establishing TCP connection. Well, you know what? Where you can rewrite the kernel about how specifically implementing that functionality is structured, that is still going to be there. Then there is a uprobe, which allows you to capture user space program calls, right? That corresponds to some specific areas in user code. And then there are some concepts as maps and perf maps, right? That allows you to store the data structures, right? And then also share the data structure between user space and kernel space programs, right? As I mentioned, you don't have to just emit some very simple metrics, right? You can actually say, hey, well, I'm going to have a hash map, right? So I can trace number of connections to understand, I don't know, let's say how long it took and how much data was transferred, right? And so on and so forth, right? For that, of course, you need to have some, transient data structures. Now, one thing which I started with years ago with eBPF is using eBPF command line tools, right? And there are quite a few those days, right? Brandon Gregg was somebody who championed a lot of those programs, right? And here is an example right here. And why I'm showing this slide is because you can see what pretty much every area of your system, both application, runtime, and then various kernel subsystems actually have a very good and simple insights out there. And the number of those tools is growing every year. Here is one of examples I like a lot, right? Is that is a tool which shows us run queue latency, which is basically delay between when a program became runnable and then they found the CPU available for that. Why is that helpful? Well, because if your system CPU is overloaded, right, there are maybe some quotas or something, and so the programs are not placed on the CPU as soon as they're ready, that gives you some added latency, and it's maybe very hard for you to figure it out because it would not show up in a profiling, because the profiling catches when a system is running on CPU, right? So there are a bunch of pretty cool tools like that. Another thing what you would see on the website is the list of eBPF applications, right? There is again a very large number of tools which are using eBPF technology, right? You can see BCC, Celio, BPF Trace. You will also find Coroot as on this page of applications, right? But I think that is something which is growing, and the ecosystem on the eBPF tools is growing more and more of those days. So what do we have with Coroot, right, when it comes to eBPF? Well, if you look at Coroot, we have a Coroot node agent, which is open source, Apache 2.1 licenses, software which does a lot of capturing the metrics for the node. And it does a lot of magic using both eBPF and some other things. Like, for example, it's discovers process containers running on the nodes. It's after magically discovers their logs, right? And for that, it can both look at what is provided with container G and journal G, but as well as when you open files in a var log, right? It monitors TCP connections and does level 7 decoding of a number of protocols. And you can use this Coroot agent with, Coroot, or you can use the code from it to, build your own observability system. That's up to you. Here are some of the ideas, or some of the technical insight about how the agent really works. The first thing is we are tracking the new process started, right? Because all the processes are going to be identified by their PIDs as a work going on in the kernel, right? So if you want to know all the metadata about the process, we need to kind of catch that during the process creation and then map it to a PID. When we are doing things like tracking out of memory killer, right? In this case, we are looking to see where the out of memory killer marks the process, right, to be killed, and then we know when that process is exits, well, that's actually exit because of a lack of memory versus something else. Here are a couple of other ideas. Is we're using a trace point to start connection and track connection ROI, so we can see how many connections are created, where those connections are pointing. You can see their latency, the traffic, the retransmits of those connections, and so on and so forth, right? And that is together with also understanding of what processes are listening on what ports, right, allows you to see the map in terms of what is talking to what, right? And I will be showing that in a few seconds. What you also are able to do with eBPF is to do level 7 protocol parsing, right? And level 7, that means application protocol, right? So we can actually look at the network and can say, oh, this is application is using HTTP to request that service, right? And we can extract from that HTTP protocol things like, URL, for example, or we can if that's a PostgreSQL or MySQL protocol, we can extract the query from it and so on and so forth. Now, if you look at the level 7 protocol parsing, it's kind of interesting, right? We have it's done in two parts. In the kernel space, we detect a protocol, right? Like a very simple, hey, do we want to capture the data and pass it to the user level? Like, for example, we are capturing the query, right, and passing that to the user level, but we are not going to catch and kind of send to the user level all the rows returned by the database, right? All the results set. That would be too much. And then later on, all that kind of additional analysis of a protocol, right? It's happened in the user level to keep the kernel footprint as small and light as possible. And I think what you can do with eBPF, which is awesome, is you can sort of break into SSL or TLS, right? How do you do that? Well, actually, you can intercept the data before, as it's passed to OpenSSL or other libraries before it is actually encrypted, right? And that allows you to get all the insights you want about the communication, right? Before, in this case, before the data is encrypted. Now you would wonder, though, in this case, well, what about the security concern? Well, and this is pretty valid thing, right? There is always this trade-off between security and observability, right? And with eBPF, we are running with root privileges, so we can access information about the tools, about the running processes, right? Including the SSL communication, right? But the tooling, of course, can be configured, so it is very careful with his data, right? Like, not reporting out any sensitive data, right? Doing only metadata analysis and so on and so forth. The next thing you may wonder is, what is the performance impact of eBPF? And I think I mentioned in this case already, is what eBPF is really designed for speed. The programs must have very small finite complexity, right? So it's designed not to really kill your kernel. Now, to be fair, of course, if you can say, what if I would try to put the most complicated program on every single internal kernel file call? Well, of course, that would be very significant performance overhead, right? But if you're being operating in a good faith, if you will, their performance overhead is likely to be quite small, right? Again, just probably, just a few percent, right? If that. So here are some of the examples what we're able to build with the eBPF. One is we can build this kind of an awesome service map, right? Where we can see what is talking to what, and we can also see how much traffic is going on between the different components, right? And what are the latency, if there's any errors, and so on and so forth, right? Then you can also like zoom in this case on a particular service, right, which gives us kind of even more insights, right, as in this case, how is that system operating. I think this is very interesting. In certain cases, we have Coroot users telling us what Coroot gave them the level of insight and understanding how really their systems work, what we didn't have before, right? Let's say, well, you deploy PostgreSQL operator on Kubernetes to provide you Postgres, but what are all those different services the Kubernetes or the PostgreSQL operator actually has, and how are they talking to each other to, provide that service? Well, they wouldn't know. Well, with operator, you can, with Coroot, you can see, and eBPF, you can see that. And if something goes wrong, well, you will be able to diagnose it. Another very cool thing what we have with Coroot and eBPF is a DNS profiling, right? That allows us to understand the DNS latency, their DNS errors, and so on and so forth, right? And this is quite often because in majority of your services, you do have a DNS lookup before, well, actual service request. And so if DNS goes down or becomes slow, right, that impacts all the system, but it will not be visible by the observability systems, which are only looking at the connections, right? Because, well, if DNS doesn't work, we don't know where to connect to. Next thing to highlight would be their cost monitoring, right? And I think that is a very important, especially in the cloud. And what you can see here as an example, we can see how much network communication costs using the basic cost model for given traffic provider, right? And yeah, including the let's say cross AZ traffic cost or egress cost, right, which can be very valuable. In certain cases, we see some misunderstanding or wrong deployment can have a very high fees which are driven by network. Now, what you also can do with eBPF is actually we sort of kind of can create the open telemetry traces, right? Well, we cannot really have a span ID, right, which allows us to connect different nodes, right? Because eBPF operating separately on a different in different nodes, but we can get an important stuff like query information and latencies as well. Now, that is to note what eBPF-based tracing comes with its limitation, right? So it doesn't have that trace ID, but it's still very useful. And with Coroot, we took an approach supporting both traditional OpenTelemetry integration as well as eBPF tracing method. Now, there is a development in the ecosystem about how maybe to use eBPF with tracing request, right? And there is a tool called Origos, which kind of does that. But what it has to do, it has to sort of like transparently modify requests, right, to inject that trace ID, and hopefully what application will define the that, right, which is nice, but also kind of more dangerous approach, right? I mean, the eBPF by default, it's kind of completely passive, like eBPF what Coroot does, I should say, right, is completely passive thing, right? It does not impact how your system functions. But if you start using eBPF to modify a payload, which you can do, right, then you have to be much more careful and implement much more testing to make sure your application is not affected. The last thing to mention here is what we can use eBPF for continuous CPU profiling, right? And again, no code changes, right, and pretty cool, pretty cool thing. And Coroot is not the only tool. In this case, there are some other tools like Periscope in the past, which provide this information, right? But I'll show you in Coroot to highlight what you can do. So we can see in this example, we find that there was like some spike in the CPU usage at this time, right? We can zoom in and understand where the CPU usage comes from. Now, you may wonder in this case to say, well, but I do not really know how do I know what is good and what is bad in profile? And this is where comparison mode is very helpful, right? Where we can highlight the baseline versus comparison as we do here, and we can see things in red. That is where we have a higher CPU usage, right? And in a green, that is very low CPU usage, right? And that allows us to understand where to focus on in optimization, if that's indeed to do. So if you look at Coroot and would like to understand how that works, that is a fantastic illustration. Right. The idea of Coroot is what you have an agent which runs on all the nodes, and doesn't have to be Kubernetes. It support Docker, VM, bare metal as well, which uses Prometheus to store metrics. It uses ClickHouse for store and log trace, and then profile. It can ingest the open telemetry you're getting from your application, right? And then we have a Coroot UI, which has a number of alerts and inspections. And as I mentioned, Coroot is open source, so you can deploy it on your own in your data center, in the cloud, you name it. To sum things up, I think eBPF is quite an awesome technology. I am frankly personally was using that since it wasn't even in the kernel main line, right? Because it was showing so much promise, and I really glad to see that pick up, right? And Coroot is one of the awesome applications which allow you to get that great insights into your systems with eBPF. With that, it's all I want to say. Let me again to remind you about open source observability day. Please register. And there are some links how you can connect with me on LinkedIn, the Twitter, right, or visit my website. Thank you. And with that, yeah, I'm happy to take some questions if there is any.
Thank you, Peter, for your presentation. And while we are waiting for questions, can you repeat for later attendees about also day, like on what day it would be, and some more information, which slide you provided at first? Like,
Okay,
some
yes,
more information, yeah.
Okay, yes, all open source observability day. Once again, that is a single day, single track conference focused on open source observability, taking place October 24th, right? We can find more information on the website, right? And we have a number of awesome speakers, industry thought leaders, which are speaking in that event. So please come, and I think you would enjoy it a lot if you are interested in observability, especially open source observability.
Yeah, thank you. And right now we don't have any questions, but I have some question for you. What eBPF tools you are using usually?
Well, I think it all depends. In this case of a news, right? This is kind of like a right tool for a job. I like Coroot, kind of obvious, right? And in my opinion, the Coroot is a very good mix of those additional eBPF command line tools, right? Where I think Coroot itself can typically provide highlights and say solve maybe 80-90% of problems. Sometimes it's kind of you have to figure out what is more complicated, and then you can use the command line tools I mentioned, and then go from there, right? If you look at the I don't know, let's say high disk I/O, right? You can use the tools to understand, well, what and where that disk I/O is happening, right? If there is any, storage stalls and so on and so forth, right? If that's network related, there are tools for that and so on and so forth.
Okay, thank you. So we don't have any questions right now, and on the social networks as well. So thank you for your time and joining us then.
Okay, thank you. Then I'll give you all guys back 15 minutes. I'm sure you can appreciate